Hey everyone, so this is going to be a series about this course CS50, and we are going to be solving its problems and labs. So we are going to be solving all of these labs and all of these problem sets, and I don't know if I will be able to solve all of these, but I am going to try. And we are going to start with lab 1 because the problem set 0 is a scratch problem. If you want to see what I did with problem set 0, you can tell me in the comments and I will leave a link for my scratch project. So first of all, I just want to say that David Malan is hands down the best professor I have ever seen. He's the greatest. I mean, I just don't have words for the way he teaches. His way of teaching is so great. Like, I really don't have words. So, with that, this is CS50, and let's start with lab 1. So, we are going to first look at the specifications. So, the problem is really simple. So, first, I want to clarify that I have already solved week 0, week 1, and week 2 problems, and we are going to be covering all of the problems, whether they are optional or mandatory. So with that, if you have watched the lecture, it is going to be easy for you to follow along. And if you have some previous experience in coding, then also it is going to be easy for you for the first few problems. And it will get harder and harder with each week. So let's see. So this problem is very simple, where the user is going to be prompted twice, first for the start size and the second time for the end size, and the output should be number of years. So the specification is that how many years it is going to take for the population to reach the end size from the start size, and for this we have to use a formula which is specified here. So let's say that we have a population of n llamas, and each year one third new llamas are born and one fourth llamas pass away. So let's say like an example is given here. So if the n is 1200, then in the first year new llamas born will be one third of it, which is 400. So that makes the llamas 1600, but the llamas that passed away will be one fourth of n, so that's 300, and 300 will be subtracted from it, and we get 1300 llamas at the end of first year. So this way we have to calculate the number of years it is going to take the llamas to reach the end size of population from the start size of population. So the problem is very simple. So for week 0, 1 and 2 we are only going to be looking at the code, and I will be just explaining the code that I have written for these problems. And for the problems after, like after week 2, yeah, after week 2, I will be making explanatory videos, and I will be like writing code. So let's see. So this is the problem solution. So I start with a variable called start size, and here is a do while loop which mm, shows the start size, which gets the start size from the user, and it will keep asking for the start size unless it is more than 9 or 9, because the population start size has to be 9. It was specified in the video. So here is a walkthrough video which you can watch. These videos are very helpful for understanding the problem. So you should definitely watch these videos to better understand the problem. And so the start size has to be at least 9. So that's why here is a do while loop. So first of all it will ask the user for input, and if the user provides an input of less than 9, it will ask again. Okay, so then we declare a variable called end size, and we do the same thing for end size, except the end size cannot be less than start size. So if it is less than start size, we have to ask again from the user the end size. So it will keep asking until the user specifies an end size of more than or equal to start size. So it can be equal to start size, which would give an output of 0 years. So let's say that 1200 llamas are in the first year, and 1200 llamas, like both the inputs are 1200, so it is going to take 0 years for the population to reach the end size, right? So if start size and end size is equal, we will just print out years 0, right? And this is the main solution. So it's pretty simple and concise. So what it does is it declares a variable years, which we are going to use to keep count of the number of years, and it has been initialized to 0. It can be like done in one line, so that doesn't matter. So, and we also declare two variables called increase and decrease. So this is the main solution, and here we have a while loop which checks for the condition if start size is less than end size, right? So we are going to keep increasing the start size for every iteration. So I'll just explain this while loop. So let's say that the user inputs. So I will what I will do is I will just um, show you in the terminal the implementation of this program. So I'll just do cd population. Okay, so here these lines of code are getting executed, and if I enter an input of less than 9, let's say 8, it will again ask me the start size. So until I input uh, 9 or more than 9, it will keep asking me. So let's input 1200, and the end size, uh, let's say 1300. So the output should be 1, but how it is getting to that 1? So from 1200 to 1300, for the first iteration the start size is 1200 and end size is 1300. So the start size is less than the end size, so we are going to go inside this loop, and the number of years is going to be increased by 1 because we are inside the loop. That means that 1 year at least has to be taken for the population to reach that size. So that's 1 added to the number of years. And now we are going to see that by how much the population is going to increase. So that is our increase variable. We are going to store this in this variable, and it's simple: start size divided by 3. And same for decrease. Here we divide by 4 because the population decreases by 1/4. And we also change the start size variable's value. How? So we had the original start size of 1200, and the increase should be 400. So assume that here it is 1200, here it is 400, that's 1600, and decrease is 300. So that's here, and if we subtract that, we get 1300, right? Now we have 1300 as the start size variable's value for the next iteration. So now when we come here, we have 1300 here as the start size value, and end size value is not changing, that is 1300 already. So now the start size is not less than end size because 1300 is not less than 1300, right? So we are not going to go inside this loop, and the loop will stop, and this line will be executed with the number of years stored in the years variable, right? So that's what's happening in this problem, and I will just show you. So if I press enter here, you can see that years is 1. So let's calculate what happens when we input some other size population. So because the end size is 1300, it is showing years as 1. Now if I do this again, and let's start with 1200, and even if I put 1301, so on the second iteration this will be 1301 and this will be 1300, because the start size variables value would have been changed. And so 1300 is less than end size, which is 1301. The loop will execute again, and the years variable will be increased by 1, and all of this will be done again, and we should have an output of 2 years. So as you see that we have an output of 2 years here. So this is how this code works, and we are going to be solving other problems also. So I'm going to be uploading these videos very soon, and if you're interested, let me know, and I can like code this again for the upcoming problems if you're interested. So these are all the problems that I have already solved. So you can let me know in the comments on what I can improve, and any feedback would be appreciated. Thank you.